Darko Mesaros is a principal developer advocate at Amazon Web Services, a prolific Twitch streamer, and is the sultan of vintage computing exploration. In this episode, we discuss our favorite announcements from reInvent 2023, and we dig into why staying curious and experimenting is beneficial to lifelong learning and adapting to new technologies in your tech career. Welcome to the show. How's it going?
Hey, well, it's going pretty good. How are you?
Never better. Never better. Have you recovered from reInvent yet? Are you completely recovered?
I am. So, the thing is, when you go to reInvent, it's a couple of things. It's like all the people. It's lack of sleep. And it's also Las Vegas. So I'm going to blame Las Vegas for everything there because being in Vegas for a week where you don't sleep is just a nightmare, to say the least. But I'm good now. I'm ready. My voice is slightly hoarse, but I'm getting there. Did you recover from Vegas?
Yeah, so I did kind of recover. So when I got back, I had a red eye on Friday, and as soon as I got back in the morning, we basically had to turn around, and my kid plays travel hockey, so I had to drive up to like Dayton, Ohio, and stay for 2 nights. So I actually really didn't get home until almost Monday. After that, I kind of came home and just crashed. I was burnt out like never before.
Well, luckily for me, I'm actually, this is my last week of working this year. So after this Friday, I'm going to take like 3 weeks off and I'm just going to just play Minecraft and do nothing. So that's going to be
That sounds like a good idea. Actually, after this week, and I'm taking a half week next week, I'll be taking some time out too to recover.
As you should.
Yeah. So I remember so when we met I guess to the audience, this is going to be completely unscripted. Usually I have some sort of seed questions, but I have enough, packed into the cranium that I would like to ask here and talk through. So it'll be good. But I remember when we first met in person, it was like last year at the AWS DC Summit. I was presenting and you did some like debriefing like style interview after I got done and like wiped
I was doing some camera work with you, so yeah, it was fun. It was great always meeting you. And that's the thing, like going to those kinds of events, of course reInvent is the biggest one, but even going to the smaller summits, it's always great to meet people and make these kinds of connections. So
yeah, and summits aren't exactly small. They've gotten pretty big. Like New York and DC are the ones that I've been to anyway, and it's pretty gigantic, all things considered.
It's big, and I always say, like, if anybody out there has a chance to visit an AWS Summit, it's amazing because, number one, it's free, right? It doesn't cost you anything. It's free to enter. There's free coffee and free food, so why not? But also you can use it for like opportunities to network with people. You can learn things, go to those wonderful talks. There's so many things out there you can kind of check out, experience, and of course, potentially gain some benefit from.
Yeah, I was so nervous at that one too, because I'll tell you what, usually I do like PowerPoints at the big ones. And I thought for this summit, I'm going to do like live coding. I'm going to have live infrastructure. I'm going to build some stuff. And the internet, there's so many folks there. The internet was just kind of flaking out. And I was testing my stuff like 30 minutes before I was set to go up. And it was not having it. And I was really nervous. I thought, oh boy, I'm going to, it's going to be bad. But then I got up and everything, the internet just started doing very well and everything went smooth. So
there's two things that separate okay speakers from really good speakers. Number one, you are very well prepared. Like you are ready. You have practiced your demo 100 times. You know everything that can go wrong. You even have a recording of the demo just in case. Or you're able to wing it. I am the latter. I don't prepare. I'm horrible at preparing. But if something goes wrong, I'm just gonna figure it out as it goes. And if you can do that properly, people will appreciate that. So the worst thing you can do is, of course, just like freak out and like, I'm sorry, that was my talk. And then
I'm gonna go hide. See you later.
Yeah, exactly. Yeah. So
Yeah, for sure. Yeah, I know Kelsey Hightower he's had that happen a few times where things have broken down on stage, and his method of just going and chronologically figuring it out and making it a show.
Making
And,
it a show.
it's really awesome.
So last year, I did a talk at reInvent, and I demoed a couple of open source tools, and one of them failed. Just spectacularly didn't work. The reason it didn't work is just because I wasn't ready, and it was my fault. But it was a room of like 600 people, and everybody's watching, and my demo just stops, and I'm like, okay, did anybody see what went wrong? And everybody's just looking and trying to. So I spent like 5 minutes taking the audience through my debugging process until we all figured it out. It was a thing missing in the configuration file. So it again, make a show, make it fun, make it educational, right? Because it's not like you shouldn't just solve it and move on. Tell them how you solved it. Tell them what's wrong. Tell them how you fixed it. Because hey, they're gonna run into the same issue.
Yeah, 100%. That's great advice. Yeah, I mean, you really can't go wrong. Yeah, piecing everything together, and yeah, just the whole thing is like not getting nervous and knowing that things can go wrong and being comfortable.
Being comfortable, because I always tell people, I actually am one of the speaker coaches at AWS, so I teach other speakers how to be good speakers. One of the things I keep telling people, and this is something I learned, is that in most cases, 99.9% of the cases, everybody in the audience is on your side. Everybody wants you to succeed, because if they don't want you to go and fail, right? They invested money, time, and effort to come and learn something from you. Nobody's going to be there to make you suffer or make you fail. They're going to laugh at you because they're not. So everybody's on your side. You always have to think about if things go wrong, at least the most amazing audience is here to keep me company. So yeah, confidence. Be sure of yourself, because remember, you know more. You probably know more about that topic than the audience coming here to watch you, because they came here to learn, right?
Yeah, and having a speaker coach to that effect. So I've done so many events like over the years, and then as I've done like more things with like AWS and some other like larger conferences, they offer these speaking coaches as part of the, hey, you want to get prepared, and the speaker coaches that I've actually listened to and gone through their talk have been just so helpful, tremendously helpful, and the way that I am able to present now is probably twice as good just by listening to some of this advice. It's great.
It's so much worth it. So definitely be always open to suggestions and criticisms, because that will help you be a better speaker, no matter how good you think you are.
Yeah. And by that, so it's funny, before reInvent, so I had a beard that was probably about as long as yours. I was really digging it. I loved it. I don't know why I'm going to tell this on the podcast, but I'm going to roll with it anyway. Why not? So the night before I'm set to fly out to Vegas, it had just hit midnight. My flight took off at 4 a.m. So I have 4 hours. I have everything packed. I'm ready to go. And my sideburns are getting a little crazy. So I have 2 sets of clippers, and I grabbed the wrong set of clippers and went right up the side of my face, and it went like down to the skin pretty much. The beard and the sideburn just completely and so I'm like looking at the hair down on my shirt, and I look in the mirror, and I actually look at myself and I said, "What did you do?" And so I go up and I'm like, I get my wife and I'm like, "Hey, you've got to fix this." And she looks one look and just burst out laughing. She's like, "I don't even know if a barber can fix that." So I'm on the plane at 5 a.m. or whatever, and I have a hat like pulled all the way down, covering pretty much my whole face. And as soon as we hit land in Vegas, I ran to a Great Clips, and yeah, it was interesting.
See, like I have not seen my face in like 11 years. I have a very the beard looks okay, but I have a very slow growing beard. Like if I would shave this, at least 8 months to grow back. Like it's just really bad. So I'm really hoping not to do it. But what you just described is one of my nightmares. When I always go to like clip my beard, I'm like, is this okay? Is this the correct one? Is this the correct size? I don't want to make a mistake, so I have to kind of cut it all off because people would be afraid. So no.
Yeah, and you mess it up, and that's a feeling of dread.
Yes.
It's especially before the biggest event in the world, pretty much. Yeah,
One wrong
you ought
move
to do it the week before.
the week before. Yeah, exactly. And it's also so fragile. One wrong move and you're done. And you're done. So, but yeah,
Oh
that's
yeah.
good.
So
It looks
speaking
great.
of reInvent, reInvent's like always a blast. It's packed full of great announcements and lots of hype. And this year, no different. It was well, I guess it was a little different because it's been the year of AI.
Of course.
Do you have any favorite announcements that got kicked out, or what really stood out to you other than like getting to nerd out with like me and other builders at Buddy V's?
Yeah. So, okay, when it comes to the actual launches, I would actually say that my favorite sets of launches are usually the launches that come pre-reinvent, because the thing is, a lot of the bombastic stuff comes like during reinvent. Oh, service, blah, Graviton 15, blah, all of those like really big Amazon Q, right? But I'm a big fan of like things that are kind of, as an operations person, I like these things that kind of sit in the back and do stuff. So, for example, one of the things that was released just before reInvent is still related to generative AI. It's Code Whisper Command Line. Code Whisper Command Line is basically, if you ever used Fig on Mac OS, it's kind of that. It's like a little command line assistant utility where you can actually use generative AI to help you do command line stuff. So, like a lot of people out there, I never know how to post data to an API. I know I have to use curl and then dash X, I believe, and then I have to define the data. I always forget, right? So what Code Whisperer helps you with doing this is that it actually, you can just do a pound sign, so a comment, and do like post data to an API gateway. Hit enter, it generates you the command, and you can go. So really wonderful, really good for a lot of people who have to do stuff. And I strongly believe that no engineer, no developer ever wants to leave the comfort of their command line, text editor, or IDE. So if I don't have to open up a Google tab or something like that to kind of find which is the correct command I want to run, I would rather not do that. So that's actually one of my favorite launches.
Yeah, I actually got to mess around with Code Whisperer a little bit and some of the newer services. That's honestly, like one of the perks of being a community builder for me. I guess the biggest perk of being a community builder is the credit
Yeah. Oh, yeah.
that you get. And you get a lot of credit. You can't, one does not simply blow through all that credit unless you're deploying some gigantic instances for machine learning things or something like that. So, yeah, getting to test all these new services out and just mess around with things is,
it's wonderful. It's wonderful.
Free learning.
Free learning, exactly. And to add one more thing to the launches is that and it's also kind of like one of the things that you don't really see unless you really know where to look at about it, or actually not even that you know where to look, but unless you really need it, is like so Lambda functions, right? We all love Lambda functions. Everything runs on Lambda functions. I think next to S3, Lambda is like the pillar of the cloud. You can scale Lambda functions indefinitely. I'm going to put a big old asterisk here. You can do a lot of scaling with Lambda functions. One of the things that was released, one of the features added, one of the improvements added to the world of Lambda is that now Lambda functions are like 12 times more scalable, which means that in the past, to scale from 0 to 10,000 Lambda functions, it would take around 3 minutes, right? 10,000 concurrent Lambda functions. With this new thing, it takes around a minute. So like it's way faster. It's like just like within the scope of a minute, you can have 10,000 concurrent Lambda functions just executing, doing whatever you need to do. So that's a really great thing when it comes to performance of your application scalability. And again, I know most of us don't run 10,000 concurrent Lambda functions, but if you need to, you can. So always great to see some of the improvements behind the scenes, and I'm sure there's a lot of effort and work at play here when it comes to improving those things and optimizing. So big fan of that.
Yeah, that's not a small optimization either. That's not a small little speed improvement. That's That's a big one right
Yeah, yeah,
there.
yeah. And what is your favorite launch?
So like I'm really network infrastructure. Um, that's like my background.
Yeah,
And like the hardware, like one thing I think is really cool with AWS, and if you talk about the uh, competition with other cloud providers for AI domination, I think this is one of the things that does set Amazon Web Services apart. Is rolling some of their own optimized hardware, and I don't know what the I think the improvement for Graviton 4
yeah,
was like it was like 50% more cores and like 60 or 70% more memory bandwidth and all these things, and you even have like R8G instances getting launched into preview.
yeah.
So like really to me, like one gigantic problem I see with like AI and like I'd say like enterprise adoption of like utilizing AI is like optimizing the hardware that underpins everything, and then also like optimizing the new things built atop that hardware.
Yeah.
So the more optimized, Graviton 4, Trainium 2, yeah, Trainium
Claim to,
2,
yeah.
second gen chip for the foundation models. We're talking like hundreds of billions of parameters. I think those are like normally like at these launches I don't even care about this stuff. It's like, oh, it's cool, okay, whatever, things have gotten faster. But now like with the way that all the baggage that comes along with AI and really needing to go back and focus on optimization, I think these
Yeah.
are important launches.
Absolutely, because I think like we love to talk about being sustainable, energy efficient, and all those things. Even Werner in one of his keynotes, he says like, well, we should all just do Rust now because it's more efficient. But if you look at the other side, like large language models eat a lot of power, right? So you definitely need to have more optimized CPUs, more focused silicon that can help you do more things. Like I'm actually hoping for a world and a time where we can run LLMs on ESP32s or whatever you want to call these things in the future, right? So from optimizing the actual large language models to optimizing the storage required to even like making cheap dedicated low power chips that can run these things. So I think even if when it comes to like you're not going to run a full large language model on these ones, but in the future, why not? Why not a smaller model? I mean, it's like even a year ago, it's been almost it was thought almost impossible to run like the models locally, or it would require a lot of a lot of power. But a lot of those models are more optimized these days, and of course the CPUs are a bit more optimized. So yeah, big fan of that. I fully agree with you. Although I'm always gonna laugh at the name Trainium because I really would love to have been in that meeting where somebody sat down. Okay, friends, we're gonna have to name a new CPU that's dedicated for training. Sorry, we're gonna name a new piece of silicon that's gonna be for training machine learning models. And somebody from the back of the room, Trainium, and that's it. So I don't know if that's the case, but
It's so true.
it is.
It's
It
with
is
some of the AWS service names. You got to hand it to them. You wonder like why,
my favorite
they're
service name, Monitron. I mean, it's everything. It's everything I ever wanted to in a service to be named Monitron. Now, for the people out there, what is Monitron? Monitron is actually a physical device. It's a physical device you attach to the machines, and through the power of whatever the cloud, it actually detects potential irregularities in the machine, different vibrations, different these things, temperature changes, so it can monitor Monitron your machines and in production. So the best service name in the world, Monitron.
Yeah, but I mean, if Alexa was actually listening and you said Monotron, Alexa would think that you said Megatron,
Maybe,
probably.
probably.
Yeah,
Yeah. So
there's yeah,
this
it
year,
is what it is.
yeah,
Yeah, there's only so many names though, and there's patents for things. So like eventually, like there's only so many cloudy type. There's so many. I mean, that's one thing. When I was walking the expo this go around, some of these new vendors, I was, just thinking, wow, that's an interesting name. But then I got to thinking, well, there's only so many names that we can come up with.
we are running out of names for companies, specifically cloud companies, specifically AI companies. I think we're running out
Yeah.
of .ai domains. So it's
Hmm.
it is interesting, like, because like I think this year's reInvent had less launches than usual. Like if you go just a couple of years back, we had like a laundry list of new launches with fantastically sounding names like Tranium and Monitron and well, not Infinidash, but like, MWAA or MWA. It's manage workflow for Apache Airflow. No, manage workspace for Apache Airflow or something like that. It's like great. Yeah.
The one that I did like, normally like these names, I don't really care so much, but the one that I really did like was when they launched VPC Lattice. I was like, okay, I like that.
Yeah.
It's different. It's short. I can remember it,
You can remember it.
and yeah, very very nice and simple.
Memorable names are great, and I mean I'm always gonna make fun of this, and I'm a big fan of this service or this set of services, but AWS Systems Manager is as an operations person is one of my favorite services out there because it kind of has all of the tools I need. But the naming, I think they're doing it intentionally, because you have a service that's called AWS Systems Manager, and underneath the Systems Manager you have plenty of other managers. You have operations manager, you have change manager, you have secrets manager, you have sessions manager, you have application manager, you have a few managers underneath. So basically it's like AWS Systems Manager X manager. So it's funny, it's great, keep at it. We just need the
At
Systems
least it
Manager
wasn't
manager
like
manager.
SPOG for like single pane of glass manager or something like that.
We need a
Yeah,
manager. We need a manager next time so we can manage all the managers. So, oh my God.
there we go.
There we go. There we go.
So
yeah.
like the reason I really wanted to talk to you, have this little chit chat and such, is basically thinking about, the idea of like staying curious and experimenting with things. So you have what I would say is a very interesting hobby where you kind of collect old tech. And when I say old, I mean stuff that like predates when some of us were born.
Oh,
And
yeah.
you sort of take that technology and you do things on it that it wasn't built for, like deploying Kubernetes with a Tandy portable from like the 80s.
Yeah,
So how did this start, and when did it start?
So, okay, a bit of background. So I come from Serbia, right, which is Southeast Europe, and I grew up in a country in a time when we didn't really have a lot. Like it was economic sanctions, literally nothing in my life in my early days was a computer. Like, and actually, I grew up with a computer. I'm gonna show it to you with one of these. So this, kids, is a Commodore 64. A Commodore 64 is a computer from 1984. And I grew up with a Commodore 64. Actually, I have a book. This is a book in Serbian, and it says Commodore 64 Easy Program or something like that. And it's a book that kind of contains how to do stuff on the computer, right? And how to write BASIC. Now, why I'm saying this? I was born in 1988, way past when this computer was launched. I got this computer in 1991, and it was my only computer, primary and only computer until 2001. So,
Wow.
way past anything this thing could do. And I grew up on it. I basically wrote basic programs. I would code a game on it. Like I would just code a game by myself from a book, play it for a couple of days. I couldn't turn off the computer because I had no tape drives or anything like that. I had to just program the game on it, keep it running unless my mom turns it off, and then just play with it. So I became enamored by old computers, and as things progressed, I got better computers. When I say better, I mean in 2001 I got a 486, which was a computer from 1994. So kind of better. But I managed to squeeze as much as I can from these computers, and I felt good about it. And of course, I moved on. I got the actual modern, current day computers in like the early 2000s. And since I skipped this whole part of computing in the 90s and the 80s just because, number one, I wasn't born, or number two, they didn't exist in my country, I kind of felt amazed by like, okay, what is this thing that I missed? Like, I missed early Apples. I missed like the 1990s Pentium 2s and like specific Amiga hardware from the 90s. So I started collecting those things. And, you buy an old computer. What do you do with it? What's the, like, what, okay, cool. Clean it up. It works. I can play video games on it. Yeah, that's fine. But I can also play games on an emulator. So I decided, like, with every old computer, I'm going to try to connect it to the internet in whatever shape or form. I want it to interact with the modern world, even if it means cheating or kind of doing it in a very sneaky way. So, as you mentioned me deploying Kubernetes with a Tandy 102. It's a portable computer from 1986. The Tandy does not know how to work with Kubernetes. However, a lot of those old computers are just, or can be, just dumb terminals. Just a place where you can hit the keyboard and through a power of a serial connection, that keyboard input goes somewhere else and you get something back. So what I do is like I have a bunch of like these modems that connect to modern network infrastructure, and they just act as like remote connections to like a Linux box via Telnet or something like that. So a lot of the old computers I have around have done something on the internet, be that launch a Kubernetes cluster, or I've recently. So do you know what a K-Pro is? A K-Pro computer. I don't have it here. So K-Pro is something that they used to call a luggable. So it's a big. It looks like a piece of luggage. It's a big old heavy box. Has a green screen monitor, a keyboard that's almost basically this size, and you open it up and it like works. It runs off of floppy disks and whatnot. It's not from 1982 actually, and I managed to write some CDK, AWS CDK on it, again, through the power of a serial connection and a terminal and whatnot. So I created modern cloud infrastructure using that. Why? I don't know.
It's just cool, though. It's just because cool. Really, so, when I started experimenting with technology, like much later than you did, of course there was no cloud. And the first time I installed and set up this little Linux distribution back in the 90s called Slackware.
Yeah.
And like it didn't have there was like no easy point and click UI. Like it was largely text based and required me, the installer, to understand the system's hardware and partitioning. There was no Debian apt or Red Hat RPM. Nope. And sometimes if you wanted something special, you wanted to be special, you had to compile the Linux kernel. Exactly. And just different days now. And I feel like honestly, one of the things that so a lot of folks coming out of college, like one of my past employers actually helped manage the college intern program and sort of help place people. And I realized that, a lot of the college graduates were coming out and they didn't really understand things like how file systems worked and like some of the things that like was like the first thing that I would have learned, just because there's so many layers on top of it now. And a lot of times they're jumping like right into code. And, one of the things I wanted to ask you was like, do you think understanding these old technologies, or like even the nuts and bolts that underpin current technologies, like that's got to be useful for builders going into the future, right? Like, especially if you're thinking of like optimization, that's becoming important. Yeah. What do you think?
I absolutely agree, right? And I think, of course, to an extent, not, you potentially don't have to think about how data is written on a magnetic disk. It doesn't really matter. But you need to understand some of the basics of computer science, right? I always say, like, and I kept mentioning this a lot, is that we've lost the art of optimization. Everybody has unlimited resources in the cloud. Did I say you can launch 10,000 Lambda functions to run concurrently? Absolutely you can. You can do 25,000 if you want. So people are just basically going ham. They're just like, you know what? I'm just going to throw code, heavily unoptimized code. I'm just going to run. It's going to power through it. So understanding some of the basics, understanding what's a CPU cycle, understanding how computer handles memory, because we don't have to worry about memory handling anymore. Understanding how certain things are written to disk, maybe what format is better, what's the sector size, what's those things, will help you be a bit more optimized. I used to write application for this thing, and the Atari 2600. Do you know what an Atari 2600 is? It's the games console. Yeah. So the game console where yeah. So
I had one for a little while, but that sucker was done.
Yeah. So game console that used to run Pac-Man, and a very bad version of Pac-Man, and indeed, the console itself has 128 bytes of RAM. You can count to 128. That's how much RAM it has, and of course the rest of the memory is on the cartridge. But you have to be really cognizant of the trade-offs you make when you make a certain call to the CPU, right? So you have to do everything manually. You have to understand that, hey, if I use this system call, or it's not even a system call, this CPU flag, whatever, in assembly language, it will take 2 CPU cycles. But if I use the other one, it's going to take 3. That means I'm gaining an extra CPU cycle. Will that impact performance? Maybe. I don't know. So, of course, you should never do anything like that unless you're building for like very limited embedded systems. But for like normal systems, you shouldn't worry about that. But it's good to know. It is good to understand what is a TCP handshake. How does that work? Would a lot of TCP handshakes affect the performance of your application or not? Remember, everything takes time. We still haven't figured out how to increase the speed of the propagation of electrons in matter. So still, everything is limited by the speed of light. So you still reach bottlenecks, especially as we're talking about now with the amount of data and processing we need to do for generative AI workloads. It is insane. So understanding some of the low-level elements is absolutely useful, and that's why I think all technology, computers such as these, kind of help you understand more, because it's so simpler on these systems. There's a lot of stuff going on here, but not nearly close as to a modern system.
Yeah, I agree 100%. I would say even in computer science majors, even just going through the process of like building a computer and understanding like the different components, that definitely doesn't hurt.
My favorite thing I like to show, especially to like college students, like I used to speak to college students about certain things when it comes to computer science, is I like to show them this. So this, let me show you that.
Oh yeah.
So this, fellow kids, is a modem. It's a modem, a modulator demodulator, as they call it. So this thing used to be something we used to use to connect to the internet or to a server or something else. So these things would basically get network traffic from your computer to whatever, right? There was no TCP. Well, there was, but you didn't need TCP to use this. Like, there was none of that. It was pure just data switching, just serial connection from here to your computer or whatnot. And when I speak to some younger audiences and I tell them this thing would convert sound into data, and they're like, what? Sound into data? How is that possible? Well, everything that goes through your phone line is sound. It didn't used to be digital. It's digital these days, but back in the day, it was literally just analog signals, sound. And this thing can convert that sound, or convert the changes in that sound, to data, which is fascinating. It's such a fascinating device. And I actually encourage people out there. So if you ever heard, and I'm sure you heard about it online, like when you like see the modem sound, when like you're connecting to a dial-up connection, that modem sound contains so much coolness in it. I actually have a poster of it on my wall, the whole handshake of a modem. It's amazing. It's like, there's 2 modems. Imagine there's 1 modem and 2 modem. This one picks up the phone and calls the other modem using the phone. Literally, just a phone call. And the other one answers, hello, this is modem, blah, blah, blah. And these are my capabilities. This one responds back, hi, my name is modem blah blah blah, and these are my capabilities. The first one says, okay, let's use this capability to talk. Okay, let's do that, and they just start talking, which is glorious. It's all done through sound. Just big fan of that. Gives me the goosebumps.
Yeah. With modems, like thinking back, it almost pains me that newer technologists will never have to go through this, because it's like you and I. So I was born in '87, and dial-up, of course, the advances, the speed, and all these things from your dial-up to now, circuit switch networking, IP-based networking, having to share the phone line, not having multiple phone lines, okay, can I get on the internet? Oh,
No.
and now everything, like if you look at like where we were back in the 90s there to like where, a simple smartphone is now, like the amount of change is just unfathomable. And we're not super old,
No.
it's crazy. And it makes me wonder, like with the technologists that are coming into play right now, what is it going to look like when they've gone through that gap in time?
And in every bit of technology, like again, you and I are not that old. We are old, but like not that old. But every bit of technology in the last 15, 20 years has changed so dramatically. When I said changed, I don't mean fundamentally it hasn't changed. Fundamentally, we're still using copper, we're still using electrons, and we're still using magnets to an extent, right? So fundamentally, the CPU in this computer is same as the CPU in Graviton 4. Fundamentally, it's the same. You're making a bunch of calls to the CPU, it's doing magic with numbers and all that fun stuff. However, the exponential rise of the capacities of those things is insane, right? The capacities, the speeds, the transfer rates is insane. Like you mentioned, dial-up modem, the most we can get out of dial-up modem is 56.6 kilobytes, if you're lucky. Like, I couldn't get beyond 42 or 46 thanks to old phone lines. So like, do I have something? I have a lot of old computer stuff here. So let's bring something up. Okay, it's a television and radio licensing. This, my friends, is an 8-inch floppy disk. So it's a big floppy disk. You're most likely used to like normal size floppy disks, where
this audience has probably never used a floppy disk. I'd
probably
imagine.
you've never used a floppy disk, but when the save button, yes, the save button is. This is a normal floppy disk, right? So this is the normal floppy disk that most of us used in the 90s, and this is an 8-inch. Come on. And this is an 8-inch floppy disk. This thing has 10 times, more than 10 times the data this thing can hold, right? And this is like 130 kilobytes of data at most, depending on how you format it, depending if it's double-sided or not. So, a lot of data. But when you look at like a large language model today, it's like, I don't know how much terabytes of data is that just the model itself. So things have exponentially scaled up.
The folks training the models probably don't know how much data, to be honest.
That is also true. That is also very, very true. So, yeah.
I love how you have all this stuff just laying around. I have some old stuff too, but like I if it breaks, I get rid of it. I don't have as much old stuff anymore. I wish I would have kept, held on to some of it.
I'm fortunate enough that I can keep this collection, and I from time to time I spend money for it. I build stuff, I fix stuff. I learned sufficiently enough that I can like repair a motherboard to an old computer. So of course, if something is broken beyond fixing, I keep it as a museum piece. It looks nice. It's always nice to look at a big old beige box, and so yeah, and it's really interesting to see like how things have progressed, like from. Okay, I'm gonna take my modem out again. This is the guts of the modem, of that modem. Look at that. Yes, beautiful, glorious. It even has a speaker in the back because it's a phone. It's basically a phone. But all of this thing can now be compressed into like a single die. Just a single small die can do this and more, much more efficiently, much more fast, and yeah. but it's so
Yeah,
good
I think
having
there's
it.
only so much more we can actually do with innovation in this realm beyond, before we go to like supercomputing and such.
Yeah, yeah, yeah. And I
Um,
always say, like, again, it's still fundamentally the same thing. Like, it's still you're flipping bits. You're doing. We're still doing binary. Remember, we're still working in the world of binary as a computer from the 1960s did. We're still doing the same thing. Nothing has changed because
ones and zeros,
ones and zeros, my friend. Yeah.
ones and zeros. So how do you? So you're, a developer advocate, obviously. How do you keep up with the rapid pace of advancements? So, you work at AWS. There's, that piece of it. But
Yeah.
knowing and like advocating for AWS specific services, yeah, you have to learn those. But getting to know you a little better now, I feel like, okay, Darko, the technologist, the geek, you stay up to date with the goings on of tech more broadly. So what are your speeds and feeds and podcasts and all that stuff? How do you keep up with things?
So I would say my primary consumption, the primary method of consumption is YouTube and Twitch. So I love to consume video content. It's kind of like a thing I really love to do. I watch other people do stuff. The reason I do that is that I try to stay curious. Like one of the things I really like to do is I like to stay curious. I think like being an engineer is not. This is going to sound so cheesy. I'm sorry. Being an engineer is not about having a diploma or having a what kind of college degree you have. It's about being excited when you see this, right? When somebody shows you an ESP32, you're like, oh yes, I can do so many things with it. It's amazing. I can make my hat glow, whatever, right? I feel like I get excited for technology like that. No matter what the technology, no matter how old the technology, no matter how new or weird the technology is, I always get excited by it because I see potential in it, right? And that kind of keeps me curious. That keeps me going for looking at new things. I'm a big fan of like practical knowledge. I've never been to college. I don't have a degree. Have never been officially. I have never went past my high school, and all of my knowledge I gained was through practical doings. So, watching other people do stuff, listening to other people do stuff, is kind of that keeps me in the loop as well. And again, I advocate for you, the developers of AWS at AWS, and people who use the cloud because I advocate for myself, because I find this interesting. I find this important. I find this as a thing that can help you, kind of survive another day in your job, which is really important.
Yeah, it's funny you say. So I did go to college, but I'm a dropout. I
There you
made it
go.
almost a whole week before I dropped out
There
of
you
my
go.
local community college because I'll tell you what, I had a job. I was doing like when I was in high school. I was doing so I'd gotten a basic tech job, but I was doing consulting on the side with someone that, like, I almost was in the right place at the right time. So to kind of like back up a little bit, I had this like back surgery when I was
Okay.
younger, and my thing to pass time was learning Linux, I set up a file and print server in my home, like hardwired some stuff. Like it was a blast. And so I got to like kind of through experiment and accident and curiosity, I got to know Linux fairly well. So I had someone in my family that had me, he's like, "Hey, you want to come and do some work on the side with me?" So we did everything from like, running the infrastructure, running the networking to at one point, it was when VMware first really, hit the scene. We were doing like physical to virtual migrations, and I was getting like all this experience at a super young age. And I was like making good money at the time
Yep.
too, and I didn't have any time left. And
Yep.
I'm like, okay, I'll come back to college. But then I never did because things started building momentum and building and building and building. So yeah, I mean, college isn't for everybody,
It's
and
not.
there are certain jobs where you have to have it. But
Of course,
yeah,
I don't want to go to a doctor who's self-taught. Like, I don't want to go to a doctor, a surgeon who's like, oh, I just practice at home. What? No. But no, absolutely. And I think we are fortunate enough that our line of work, you're still able to just get better at it at home. Like, you don't have to go to school. You don't have to pay, when it comes to the US, hundreds of thousands of dollars for a big old education. You can do stuff yourself, and that is the beauty of it. And again, as long as you're interested, like why did you set up a print server at home? Like, You didn't need a print server. Like, it was cool, but you set it up because it's interesting, it's fun, it's great to do it, and that's why a lot of engineers do it. They do it just for the hell of it. It's just like you love it. It's a cool thing to try out, and then you get to try more things, right? I don't program assembly for the 6502 CPU because I think it's important. It's not, but it is fun. It is interesting. It is cool when you get to learn things. And again, I don't know. It's a self of. I think it's not self. It's a feeling of self accomplishment when you make something and it works. It's, we're all still big kids, and we love it when our toys start working, and that's it.
Yeah. And I mean, you get some, I have all these old, like, I still have probably like half my lab gear for whenever way back when I first took the CCNA. Like, in order to study for these certs back in the day, like, you had to pay thousands of dollars and order physical hardware from eBay, have it delivered to your house. Some stuff would work, some stuff would dead on arrival. You'd have to send it back, and you'd have to build this lab and then configure all of it. Like, it was so much of a time sink. And I loved it because I learned a lot and it was really exciting for me. But now, like, the barrier to entry, the barrier to learning is just, I mean, AWS free tier.
Oh yeah,
It's awesome.
awesome. And like, that's always a thing that kind of, I when I was younger, I also was I wanted to be a big Cisco guy. Like, Cisco was everything, right? In the early 2000s, like, everything was on Cisco. All the best tech jobs, well, best paid tech jobs were in Cisco. And my biggest challenge is, like, I could never practice with Cisco because you needed gear. And again, where I come from, we just couldn't buy it. Like, a single switch would be the equivalent of like half of my yearly income, which is no. And I was always surprised, and I don't know this. And here's a question for the people in Cisco: why was there no virtualization software? Why was there nothing I can sit around at home and emulate a switch and play with it? So I don't know if that came later on, but I would have really liked to have that.
It did come later on. Like, first they got like the layer 3, the routing stuff. There was a open source project called GNS3, and then since then there's actually like a lot of good software that does layer 2 as well, like, switching frames and whatnot. So that has progressed. So it's probably good to have some physical gear.
Yeah.
I honestly have some DL360s, HP ProLiants, and I'm have KVM running on them, and I do all sorts of fun experiments. Like, my home internet comes into a virtual firewall. Like, I plug it right into the back of my server. I have a NIC that's passed through, hardware passed through to the actual VM, and my speeds are just the same. It's pretty awesome.
Yeah. I mean, modern hardware is just crazy. Like, I when it comes to the home labs, I have a 6-year-old desktop computer, just an Intel. I think it's 8th gen i7. I have Proxmox running on it, so like virtualization software. And my development environment, my dev box, is sitting there. Like, I have a little Linux machine where I just do all my development on because I just like some Linux. And next to that, my entire NAS system that hosts like 20 terabytes of storage is sitting on a VM with a pass-through SCSI card. So not SCSI, SAS card. I'm just passing the whole card through it to the VM, and it just works like a charm. So
that's awesome. Yeah, I use Proxmox too. I was using ESXi for the longest time, but Proxmox KVM can do. It's awesome.
Virtualization
in the earlier days, it was really hard to set up, but now it's
But
easy.
Virtualization has gone so much, even from like the last 15 years. Like, again, 15 years ago, like, VMware was the king. Like, you had Zen as well. Zen was doing something with virtualization, which I think AWS virtualization is also based on Zen to an extent. Microsoft had virtual server, if you remember that. Microsoft had a virtual server kind of a deal. They had, of course, virtual PC, but they had virtual server as well that turned into Hyper-V. But these days, like, you have Proxmox is a fully fledged enterprise thing you can run. Like, just no joke. It works like a charm, of course, in VMware as well. It's just the advancements are so up there right now that you can easily run a full-on gaming system, gaming PC in a virtual machine with GPU pass-through and everything. It's just glorious.
Yeah, and all the tools that you use to configure everything, Terraform, Packer, all the different things, they're open source, so you can experiment as much as you want without any cost.
I'm such a sucker for automation. I used to be what they used to call a systems administrator, right? And my job was to configure systems, install operating system, install software, manage it, patch it, all that fun stuff. And the biggest pain in my life was you set up a system, you work on it, you make a change, and it breaks everything. And then what do? Do you spend the next month or week trying to figure out what went wrong, trying to do it? A lot of times I would just go ahead and tear it all down, just shut it down, reinstall, and start from scratch because it was easier and faster to do. And now, with the tools of automation, your Terraforms, your Ansibles, your Pulumis, your CDKs, your CloudFormations, you can deploy infrastructure in a minute, but you can also destroy it in a minute, which is my favorite feature.
That's the big thing right there, is destroying it. Yeah.
Yes.
It
works like a charm.
Easy.
Like one of my jobs was the title was server provisioning administrator, and my job was to install operating systems on servers, and it was done in one big telco company, and like you would get like actual physical 500 physical servers in a data center like in Fairbanks, Alaska, really far away, really slow connection, and you have to install the OS on it remotely from Europe. And the way I would do that is like they were usually IBM servers or Dell or HPs, and you take your favorite Java-based remote administration utility, you take a mouse, you mount an ISO, and you go next, and do that 500 times. Oh my god, that was
talk about tedious.
And like every system needs to be reconfigured. Sometimes it's Linux, sometimes it's Windows, sometimes it's Solaris. So it was a lot of those things, and just I'm so happy with today's automation capabilities. So thank you, cloud, whatever cloud you are. Thank you, cloud.
Likewise, I'm an automation junkie myself, but yeah. Hey, so one, I guess I want to ask a few more questions. So I know, like at the moment, the whole world kind of is revolving around AI is like the emerging trend. It's almost so polarizing. It's kind of getting it to be a bit much sometimes. Yeah. But are there any other emerging trends or new tech that you think is promising aside from AI, that you're excited about?
My excitement now is that, and this is maybe biased because I'm a fan of old technology, and sometimes in the olden days we had numerous different CPU architecture types, right? In the past, you had x86, you had PowerPC, you had Spark, you had MIPS, all of those different CPU architectures that were really good for something. And then what happened all of a sudden is like all of it was gone, just gone. The only thing we're left with is x86, and of course your phone, and then which is ARM. And then all of a sudden ARM is coming back, like from desktop hardware like Apple stuff to mobile phones to now server hardware. I'm hoping that more and more people invest into things like RISC-V, different CPU architectures that are going to be more efficient, more well built for that specific task. And then we get I hate to use the word, but we get a quantum leap in performance, in capacities on CPUs just because we choose to use a different type of architecture. So that's kind of my thing. I feel like we're going to have a lot more dedicated hardware for certain things, a lot of dedicated instead of GPUs, we're going to have what are they called? There's another PU for machine learning. Is it MPU?
DPU?
Or DPU? Something for machine learning specifically. Some chips, silicon specifically made for machine learning. So I do feel like a lot of more custom silicon, custom architectures are going to be part of the entire world. So, and hopefully that brings us faster things and, well, more efficient, if anything.
Yeah, well, even like ARM. So like my wife, she had a brand new MacBook, but it was the Intel, the last iteration of the Intel version. And when I started working with Alkira, I got an ARM MacBook, first gen. And my battery doubles her.
Easily.
With the brightness, like, I don't know how it does it, because I always thought the screen is what just drained that sucker. And that's a lot of it. But that processor is very efficient, and I can go all day without plugging that sucker in. It's
I
great.
I have a first gen MacBook Air with the M1 chip. I went on a cruise, 5-day cruise. I didn't charge my laptop for 5 days. It just like worked. I'm like, this is crazy. Like, it's amazing because it's more efficient. Like, it's a 5 watt chip, which is insane for
Yeah.
and of course for the performance you get. So that's the thing. I'm really hoping that some other manufacturers, some other things come up. They say, hey, listen, um, this is how you can do it, and thanks to the speeds of those chips, um, cross compiling, building different things, or even just kind of emulating things on them can be seamless, right? In the past, of course, it was a lot more difficult because of the limitations of hardware, but no matter what kind of hardware you use now, I feel like software should be plentiful.
Yeah, absolutely. Yeah, that's a good point about the CPU architectures.
Yeah.
Yeah, because if you would have told me that this would have been possible 10 years ago, I wouldn't have believed you,
No.
especially with the battery life and the optimization and such.
Yeah, and
But yeah,
ARM is an old architecture. It's like ARM is actually an acronym for Acorn Research Machines, and Acorn. That's where Acorn. Acorn is a computer company from the UK, which used to produce Acorn computers, like in the time when the ZX Spectrum was a thing. So it's like the early '80s. So they're an old architecture. They're old, but they've been expanding. Like, everybody's phone is an ARM computer. So
and they have
absolutely,
ARM instances in the marketplace. So they're everywhere now.
yeah.
It's a
So
thing.
I actually
Yeah,
encourage people to switch to ARM whenever they can, because again, it's more efficient. It is less costly for the amount of performance you get. So if your EC2 instances are running a general purpose workload, something you feel like I can give that a shot, check out ARM. Definitely.
for sure. Well, it's really been, I guess we're up to about an hour now, so I guess it's quitting time.
Let's quit the
Where can the folks find you? And by the way, this has been a great conversation. I've had a blast just
same.
nerding out with you.
Same. I could
Um,
talk about this all the time. So, where can people find me? I think the best way to find me and the best way to reach me is LinkedIn. So go to linkedin.com and search for Darko Mesaros. You will find a big bald head with a beard, and you can find me there. I think that's the easiest way to do. I'm also on Twitter as well. You can find me there, but I tend to spend a lot more time with LinkedIn, and I tend to get a lot more great interactions here. You can also follow me on Twitch, twitch.tv/AWS. That's where I stream a lot. So I do a lot of live streaming there. So you will find me there. And I guess, at a retro computing convention near you. So
awesome. Thanks. I'll put those in the show notes.
thank you,
And
Ryan.
yeah, thanks again for coming on. Really appreciate it. Love the hat. Love the decorations in the office.
Thank you so much.